Now we've been looking at left-sided limits and right-sided limits. Example 7 goes actually over a pretty common type of limit that we see in calculus. It's asking for us to evaluate the limit as x approaches 0 of the sine of x over x. Now just from our table we see that as we approach this limit of 0 from the left side, so we're approaching 0, we're to the left of him, we are approaching the limit of 1. Okay? So from the left side, it appears that we are approaching that limit of 1. On the right side, as you approach 0, getting smaller and smaller and smaller, and closer to 0, we see that we end up with the limit getting closer and closer and closer to 1 as well. Even from our graph, we can see that as we approach 0 from the left, it is in fact approaching that limit of 1. Likewise, from the right side, it's approaching that limit of 1. There is in fact a hole there. The reason for that is if you were to set this bottom not equal to 0, you would see that obviously you would get that undefined statement that x cannot be equal to 0. Now there is a hole there though. And the question is why is there not a vertical asymptote? Well, we're actually going to be talking about that in some future notes. But for right now, we can just see based on the tables and the graph that this will not actually come out to be a vertical asymptote and that there is in fact a hole there. And so how we actually show this is we have the limit as x approaches 0 from the left of the sine of x over x is equal to 1, coming from this first part, the left side. The limit as x approaches 0 from the right of sine of x over x is equal to 1. And as a result, so because the left worked is equal to 1 and the right one worked, you got a limit and it's also in fact equal to 1. So then the limit as x approaches 0, just in general, not specifying left or right, of this function sine of x over x is equal to 1 entirely. So in other words, whenever you see this type of limit in the future, you know that that limit is in fact 1. Okay, so that's going to be handy for some future problems. And again, in the future, we'll talk a little bit more about why there's not a vertical asymptote there. So again, that is example 7 from our 1.2 set of notes.